Hey, what's going on, guys? Hope everybody's doing well and having a great day. A few weeks ago, I mentioned in a video about the possibility that Earth may not be a planet, that it could be something else. And I want to talk about what those something else's could be in this video. And I want to let everybody know from the beginning that this is just a theory. It's just an idea that I've had for a while now. And I just want to share the idea with you guys and see what your thoughts are. And maybe you agree, maybe you don't agree. Either way, that's fine. I just wanted to share my thoughts with you guys on what I think Earth quite possibly could be. But first, over here at the homepage of the website, today's feature photo was sent in by Bruce Taylor. Not sure of the location, but that is one awesome sunset. Thank you, Bruce. Really appreciate that. And checking in on the GOES X-ray flux over here at the Space Weather Prediction Center, starting to climb just a little bit. No major flares, but we could see some here in the next 24 to 48 hours. Schumann resonance, once again, very, very quiet. Hopping over to the Yellowstone supervolcano caldera, looking at the seismographs that monitor the mighty supervolcano. A little bit of activity along the northern edge of the caldera. Once again, we're seeing small earthquakes at Mammoth Vault and along the northeastern edge of the supervolcano. Other than that, pretty quiet at the supervolcano. Looking at the power outage situation across the U.S. Right now, 51,000 customers without electricity in Texas, as there's been a series of large storms move across the east central plains in the last 24 hours. Large hail, high winds, and very heavy rains. And once again, guys, this is just a theory. We're going to start off with a question. What if we could encapsulate the sun with a 4,000 mile thick layer of cosmic dust? Would it become a planet like the Earth after it was encapsulated and cooled? More than likely, it probably would be very much like the Earth. And this is what I think happened to the Earth many, many years ago. After it was encapsulated with the dust, it began to slowly cool, and once it cooled to a certain degree on the exterior, the interior remained what we know today at 10,000 degrees Fahrenheit. Once it cooled completely, cracks began to appear in the surface, and from those cracks, gases began to leak, causing the Earth to freeze because the Earth became engulfed in a variety of gases, causing the entire planet to freeze. And as it thawed, many layers of atmosphere rose up from the surface of the Earth, and the ice converted from a solid to a liquid, the liquid that we know today as the many oceans. Those atmospheric layers began to trap heat from the sun, creating weather patterns that swarmed the Earth, and the remainder of the ice began to melt with the exception of the polar ice caps, covering the entire Earth with water as all of the ice melted, again with the exception of the North and South Pole. The water activating photosynthesis, which created oxygen and an abundance of oxygen surrounding the entire Earth. But how do we know Earth has a specific 23.5 degree tilt? Maybe it's because of its shape. Maybe the Earth is larger below the equator that creates this tilt. What if the Earth were shaped more like this, like a pear, larger below the equator, a little bit smaller above the equator, and that would make it much easier to identify a tilt in the Earth opposed to a perfectly round Earth. I think the tilt in a perfectly round object would be very difficult to find. Or could it be shaped something like this? Some people say that the Earth is shaped like a big geode, something like this right here. Very ununiform. I do think the Earth is bigger on the bottom, maybe not quite this large. This is simply an overlay. But I do think the Earth is bigger below the equator, and that does create a permanent 23.5 degree tilt, and that makes the 23.5 degree tilt easy to identify. And then again, maybe it's neither. Maybe it's not pear-shaped, maybe it's not spheroid-shaped. Maybe it is perfectly round, and then some will argue that point. You know, it's a topic of great debate. I, however, think that the Earth is slightly larger on the bottom than it is on the top. But here's the question that I have. How does the Earth stay so hot? 10,000 degrees Fahrenheit in the center of the Earth, and that's a constant. From what we're told, it is like that all the time. And here's the many layers of the Earth, 4,000 miles thick, and the sun, a star, has a hot core just like the Earth. The only difference is the sun is not layered in cosmic dust. So what if, just what if, the Earth were actually born as a very small star or a fragment of our very own sun. Just what if? That's how the interior remains so hot all the time at a constant 10,000 degrees Fahrenheit. When the sun came out of the stellar nursery, right over here on the left, you can see various types of stars that come out of various types of stellar nurseries. Maybe it wasn't alone. Maybe it had with it what we know today as Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. But when they came out of the stellar nursery, they weren't like this. They weren't planets at all. Maybe they came out as various sizes of small stars. And maybe when the accretion disk, the sun being right here in the middle, in the very early stages of the sun's life, the accretion disk was full, absolutely loaded, just like this here, with cosmic dust. It goes on to say here, Earth formed about 4.54 billion years ago by accretion from the solar nebula, a disk-shaped mass of dust and gas left over from the formation of the sun, which also created the rest of the solar system. Look, just like that accretion disk that I just showed you guys in the previous photo. Here's another example of an accretion disk. These smaller, unformed planets, basically very small plasmoids or stars, began to orbit the sun in this very thick dust cloud. And as they were orbiting the sun, they were collecting the very thick cosmic dust that was surrounding our very young sun. And some parts of the accretion disk were thicker than others, so the parts that were thicker, the orbital that was orbiting in that orbital path, became a thicker planet, eventually collecting most of the accretion disk dust from the early stages of the sun when the sun was born, becoming the planets that we know today that are still orbiting in the same location that they were in the very early days of the accretion disk when it was full of dust. That dust has surrounded these very small stars that we know today as Mercury, Venus, Mars, and the Earth. And the larger rocks that were not dust formed their own orbit, becoming what we know today as the asteroid belt between Mars and Jupiter. Right there you can see the asteroid belt in this diagram. But it seems like the interior of the Earth is constantly trying to escape, as the surface of the Earth is full of leaking volcanoes, some active and some not active, but they are all over the Earth on land and under the oceans. The hot magma, it's magma when it's under the surface. When it penetrates the surface, it's known or recognized as lava. The lava then dries and becomes land or stardust. Plasma is a form of a star, and to me, that's what's in the center of the Earth. It was once a very small star. All stars oscillate, and the Earth oscillates as well. Earth's core found to oscillate, changing the length of days. This was just confirmed by scientists a while back. And speaking of stars, all stars of all shapes and sizes oscillate. In many cases, these oscillations are created by standing waves formed inside of the star. Just like the Earth, the oscillating comes from the interior, just like it does with stars. And in this next graph, this is a life cycle of various types of stars. And I think what we live on is a type of brown dwarf star. I really do. That's how the interior maintains that 10,000 degree temperature. It's always hot. If it were some sort of a planet, it probably wouldn't have a very hot interior. Is Earth a type of a brown dwarf star? And that brings up the question. What exactly is a brown dwarf star? A brown dwarf star, an astronomical object, is an intermediate between what we know as a planet and a star. It didn't quite reach full-blown star status, and I think what happened is this. It started out as a very small star, got caught up in the orbit around its parent star in the early stages of its very young life, the main star, and it got caught up in the accretion disk, got covered in way too much cosmic dust, much like the Earth. The Earth is covered in a 4,000-mile thick layer of cosmic dust, I think turning it into a brown dwarf. We recognize it as a planet, but the interior, it's that interior that's 10,000 degrees Fahrenheit. The interior had to be first. That's the way I look at it. The interior was first. The cosmic dust and the many layers of the Earth were second. The interior of the Earth was enveloped in a very thick layer of cosmic dust, making up the many layers of what we call planet Earth. But the interior of the Earth is constantly trying to escape through cracks in the Earth in the form of gases. It's constantly trying to escape through the thousands of volcanoes that are all over the Earth. Many of the volcanoes we don't even see because the volcanoes are covered with water. Earth is a very unique place, surrounded by liquid water, the only known place in the solar system to have that. That creates an abundance of life. This place is thriving with life, not only in the seas, but on land and even in the air as well. But however you want to identify this place we call home, one thing's for sure, it is very, very unique. Thanks for the photos and videos, guys. Keep them coming. If you guys have any photos you'd like to share, you can send those to reports@mrmbb333.com. If you guys have any videos you'd like to share that are too large to attach to the email, come over here to the homepage of the website. You can always find a link down below in the description box. Look for this red banner that says, have a large video. It's a Dropbox. Drag and drop your video into the Dropbox. Please include your first name, date, and location, and I'll take it from there. Thanks for watching. Have a super day, and be safe out there.